This Flutter code passes review. Tap one button and the field forgets everything you typed. I fixed it myself. The text came back, and the keyboard is still closed on every single tap. So, where does the text live?
Here is the app. It takes meeting notes, one text field, and a floating button that paints it. You type, you tap paint, and the field keeps your text inside the colored container. The whole file is 48 lines, one bool for highlighted, one text field, declared once, used in both branches. If it's highlighted, I wrap it in a container. If not, just a field. That conditional wrapper is the idiom every Flutter codebase has in it somewhere, you know. The diff a reviewer approves says wrap it in a container when highlighted, and that's all it does. Flutter analyze is clean. And look at this line. The field is const, one object handed to both branches. So a reviewer reads one field, not two. So I didn't debug it. I gave it to an agent, one prompt, hands off the keyboard. Users report the meeting notes field loses everything they typed when they tap the highlight button. Find the bug and fix it. That's the whole prompt. The only other thing I typed all session was, do what you think is right. And it ran on a stock install. No user memory, no plugins. It took 3 minutes. It found the bug, named the element tree, patched 2 things instead of 1, and wrote 3 regression tests. Then it stashed its own fix and ran them against the broken code to prove all 3 failed first. In its word, a regression test that passes on broken code is worthless. Flutter Analyze is green. 3 tests pass, and the text stays put on a real phone. That patch lands in your review queue on a Tuesday, and you approve it. Real phone, real build. I type budget meeting with Sarah, Q3 numbers. It's there. I tap paint. Gone. The container shows up. The hint is back, and what I typed is not anywhere. Nothing crashed. No exception, no red screen, no line in the console. This is a small app, and I built it small on purpose. It's not a small bug. I have shipped forms where a branch swaps elements based on what the user does. You ping an API, the response lands, part of the form gets replaced. Then the user hits submit, and the server says a couple of fields are empty. So, in that sense, you hunt that for hours, if not days. And I should admit something. I have been shipping Flutter for years, and I never went deep on the 3 trees. I knew what they are, but I didn't know the sequence in depth. The text was in the field. The field is still on screen. So, where did it go? Let's watch it instead of guessing. I wrap the same text field in my own widget. It prints a line when its state is created, and one when it is destroyed. Type, tap, 2 lines, every tap. Field created, memory empty. Field destroyed, your text died here. Now, read the order, because it reads backwards, and that is the whole thing. Created prints first, destroyed after it. 38 milliseconds later on the first tap, 23 on the second. That is not one field born and then killed. There are 2 state objects in those 4 lines. The framework inflates the replacement during the rebuild. So the new one runs in its state first. The old one is not gone yet. It dies at the end of the same frame, and those 38 milliseconds are the gap. So the field you are looking at is not the field you typed into. It's the new one with an empty memory. And the widget inspector shows the container arriving between the padding and the field. So I asked the agent the question I cared about. Which tree did this live in? And what happens to my state object when I tap? The element tree. That is the one with identity across frames. And a stateful element is the thing that owns your state object. Here is the sequence, step by step. Out of the framework source on my machine. Flutter 3.44.1, Dart 3.12.1, the same SDK that built the app on that phone. Set state marks the element dirty. Build runs again, and Flutter walks the new tree against the old one slot by slot. At the slot where the padding keeps its child, it calls update child. And update child asks one question. Can I update it? So it calls canUpdate. And canUpdate checks for the same runtime type and the same key. That is the entire test. Before the tap, that slot held the text field. Now it holds a container. Different runtime type. So false. And false means no reuse. The old element is deactivated. And a fresh container is inflated with a fresh text field under it. Deactivated is not dead yet. It sits on an inactive list until the end of the frame. And when nothing pulls it back, finalize tree unmounts it and unmount calls dispose on the state. Here is what dies. A text field you pass no controller to creates one for itself inside its own state and disposes it there. Your text was never in the widget. It was in that state object. And one line above the controller in the same dispose sits a focus node, the field also made for itself. 3 lines of code kill both, which brings back the const. The agent said it better than I would. Widget object identity is irrelevant. Reconciliation compares type and key at a position, never object identity. Same object, different position, dead state. The text and the focus live in the same place. So a fix that saves one and not the other is going to look exactly like a fix. So here's my fix, and it's the one most people write, I would say. Move the controller up into the parent state, dispose it there, pass it down. The text stops living inside the thing that dies. Type, tap. Text is there, fixed. Right? Look at the console. Created, destroyed. Both lines, every tap. The field still dies. The text survives because it lives one level above the churn now. And look at the phone. The keyboard is down. The caret is gone. I tried to keep typing and I'm typing into nothing. The text came back and the user got thrown out of the field mid-sentence. That is not the fix. That is half of it. Now, the agents patch. This is where I stop feeling clever. The first hunk is my fix. Same lines. A controller on the state class, disposed in dispose, passed into the field. And then it keeps going. It keeps the container in both states. So it never appears and disappears. Only the padding and the color inside the decoration change. So now canUpdate at that slot compares a container to a container. True. Update child takes the update branch. Nothing gets deactivated. And it walks one level down. Text field against text field. Also true. Nothing under there dies. So the state leaves. The focus node leaves. The keyboard stays up. And you're still in the field. The agent wrote my fix. And then it wrote the half I missed. And it was one property name away from missing it too. Container is a stateless widget, not a render object. And it inserts a colored box only when its color property is not null. The agent put the color inside decoration, which is set in both states. Use color instead, and that layer appears and disappears. canUpdate fails one level down, and the bug is back wearing a fix, one property name. That is the distance between the fix and the bug in a custom. So, how do you tell them apart? When the diff reads fine either way, you run it. 6 variants of the same screen. one script against each. Type a sentence, tap the button, then read three things: the text, the focus, the keyboard. A is the bug. All three false. B is my fix. Exactly what the phone showed. C is the agent's patch. All three true. D is the one I didn't expect. That's the agent's patch with the controller move back down into the field. Stable tree only. The field creating its own controller again. Text, focus, keyboard. All three still true. So, moving it up did nothing for this bug. The stable tree is doing all of it, and it makes sense. If that text field element is never deactivated, its state is never disposed. So the controller it made for itself never dies, and I would still keep it. Moving the controller up is insurance against a tree change that hasn't happened yet. Insurance is just not what saved the text today. Now, the agent's own summary caused these two independent problems. So, two parts, both needed. Every sentence it wrote about the mechanism is right. The partition is what is wrong. One cause, two symptoms. Same subtree, same tree lines, so fixing the tree fixes both. Nothing flags that split. The diff reads right. Flutter analyze is clean. Its own three tests pass because the behavior is correct, and that is what they test. At the end of the day, the only thing that finds it is a person reading the patch, which is what I do anyway. That patch is good. I would ship it over mine and still not merge it on its word. I read the code in the project first until I understand what was done and that it matches how the project is built. A session that doesn't know your codebase writes in its own style. Then I check the linters and possibly Codasy on top of it. Then I send it for review. Actually, not even that. First it goes on a real device and I play QA myself, hunting the edge cases I already know about. Then the tests. Which ones did it right and which one is missing. Then the PR, where other people and other agents get a look. Then CI. One more time.
Two fixes, and they were never equal. Mine brings the text back, and the agents keeps the user typing. I would ship the agents and send mine back for review. The rule I would carry out of this: your state leave at the position in the element tree. Change what sits at that position and it dies, no matter what your widget variable says. And never trust an agent 100%. It wrote a better code than I did, and it still handed me a summary that split one cause into two problems. Repo is in the description. 6 variants, runs in 2 seconds.